So here from number 20, we've got another sequence, and we can see that every step of the way we're doing the same thing, and every step of the way we're multiplying by 1/2. So this is a geometric sequence, okay? But this doesn't look like our normal sequences. These are all in y equals form. So it's wanting to know which one of these equations is going to fit this sequence. Well, the easiest way to test that is to abuse the fact that this is a multiple choice problem, okay? A multiple choice problem. What this means is my a sub 1 is 400. So if I take that a sub 1, that number 1, and plug it into the equations, I should get 400 as a result. When I test this first one, that would be 400 times 2 raised to the 1 power, because I'm taking this 1 and plugging it in. Well, that results in 800, so that one did not work. It has to result in 400. When I do it for my next set, I have 50 times 2 raised to the 1 power. You put that in the calculator, and you're going to see that your result is 100, which is not 400. Now we start getting into some of the messier ones. We've got 1/2 times x. Well, x is just our number 1, same as earlier. We're taking this number 1 and plugging it in for x every single time. Then that is plus 400. This is going to seem close, but it's not quite right. This one, if you plug it in the calculator, you're going to get 400.5. That's close, but it's not 400, so this one didn't work. Just to be safe, you could plug in 400 times 1/2 raised to the 1 minus 1 power, which would be 0. Well, anything raised to the 0 power is just 1. So essentially, this boils down to 400 times 1, which is 400. A key thing to note, on the actual test tomorrow, you need to check all 4 answers for multiple ones, okay? And what I mean by that is take a sub 2, take this 2, and also try plugging it in. Because sometimes you're going to have multiple correct answers. The number 1 might have worked on 2 or 3 of these. It might have only eliminated 1 option. So you might have to go 1 step further. Number 21, if these 2 equations are graphed, how can you find the solution? And we reminded y'all this, we harped on this whole semester. Whenever we're solving these systems, what we're looking for is an intersection point as a solution, okay? So that's your answer is B. Find where the lines intersect. Find where they intersect. For number 21, should have been B. Number 22, solve the system of equation using substitution. Guys, there's nothing about this that actually forces you to use substitution. There really isn't. If they didn't ask you about a step or ask you to show your work or make an open answer, you can answer this however you would like. I wouldn't do substitution. If you wanted to do substitution, you would take this 2x plus 4 and you plug it in for y. What that is 2x minus 2x plus 4 equals 6. You'd simplify all that out and get x by itself. Then you'd take x, plug it back into an original. It would work. But I don't want to do it that way. I'm a lazy man. I look and say, well, this one's already ready to graph. So if I want to do my graphing in blue, this one's ready to graph. This one is almost ready to graph, okay? If I subtract 2x from both sides, I've got negative y equals negative 2x plus 6. Divide by negative 1, divide by negative 1. Y equals 2x plus 6. And there, I'm sorry, minus 6 should be, I believe. Minus 6. And now both of these are ready to be graphed. I throw them in my graphing calculator. And as you can see, when I take these 2 equations, I already had them plugged in. And I zoom 6, I end up with 2 equations that are never going to intersect. So it tells me to solve by substitution. Unless they force you to use substitution, you can use whichever method you would like. Okay? Therefore, D, no solution. 23, which relationship describes a function? What makes it a function? To find a function, we need all of our x values to be unique. We need no repeat x values, which means no repeats in the domain, okay? So we look at this first one, -2, -2, -6. Did not work. 2, 3, 3 did not work. 2, 3, 3 did not work. -2, -3, -4 did work. Each member of the domain, which means x values, is assigned exactly one member of the range. There's our answer. 24, for the data set summarized in the box and whisker plot, identify the mean. Okay, well, think about our box and whisker plots. We have a min, Q1, a median, a Q3, and a max. Nowhere up here do we have the mean. Could you estimate the mean? Yes, but we cannot identify the mean. We do not have enough information. Box and whiskers do not give us the data set, and they do not give us the tools we need or the straight answer we need to find the mean. Okay, we can find the median, that's not the same. 25, table below, temperatures in Chicago. We want to know which measure of central tendency gives the least accurate prediction. A little note, it says be sure to choose a measure of central tendency. Well, we know our only measures of central tendency that we use are mean and median. Okay? Next, I want to know, is this data skewed? When you look at it, it looks like it probably will be because this is going to be an outlier of 55. But just to be safe, you can hop in here in your calculator. When you go stat edit, you can see you've got your lists. You type in your data. For us to use the mean, our data has to be symmetric. For our data to be symmetric, we need our mean and our median to be roughly equal. Here's our mean at 21.625. Here's our median at 17.5. Okay, so our mean did not equal our median. That means we have skewed data. In fact, it would be skewed right. Skewed data always uses the median. Symmetric data always uses the mean. That was one of our big distinctions from that chapter.